Hello, I'm Tommy Minyard. I'm Director of Advanced Computing Systems at the Texas Advanced Computing Center, TACC. I'm been here for almost 20 years now, a longtime employee. The Texas Advanced Computing Center, located at the University of Texas at Austin, we're responsible for supporting research computing here at the University of Texas and across the country through our National Science Foundation funding. We've had a long history of DDN hardware here at TACC. We've used it for supporting a lot of our research computing activities. Most of our focus is on academic computing. We support a wide range of researchers doing everything from computational modeling, simulation, molecular dynamics modeling, computational physics, astrophysics, all the way down to machine learning, AI, a lot of these new paradigms of using data and big data to do analytics, and DDN has been instrumental in helping us solve some of those data challenges. Right now, we currently have over 100 petabytes of DDN storage inside of our machine rooms, doing a variety of different roles. Not only do we have the DDN SFA and controller appliances acting as large-scale parallel file systems, but we also support other paradigms using the DDN hardware, such as data archiving, data repositories, being able to share and annotate data, including even supporting HIPAA and protected data on some of our DDN hardware using encryption and some of the technologies that DDN has provided to us. In terms of our current other activities, we also have 30 petabytes worth of DDN hardware on our archival tape storage. It acts as the front end for anybody interacting with our tape library. And then, of course, our newest DDN hardware is what we have attached to our flagship system, Frontera. Frontera is our 40 petaflop system, approximately. It supports the highest end researchers at the National Science Foundation. These are the researchers that are pushing the limits and boundaries of high performance computing, AI, machine learning, and need the capabilities of a system like Frontera with 8,000 nodes and over 50 petabytes of storage from DDN. In addition to having the 18K controllers, these are the embedded controller exascalar appliances that act as luster appliances. We also support the IME burst buffer technology as well. We have a deployment of over 3 petabytes of IME storage here that we're using in front of one of our luster file systems for people doing burst buffer and using the NVMe flash storage at very high performance. In addition to that, we support multiple luster file systems, including what we call our site-wide file system. We've got 20 petabytes of DDN storage acting as a site-wide file system where users can access that file system from any of our production resources, and it makes it real flexible for them to do data analytics on one platform, potentially move it to another platform for visualization or for further analysis that might not be capable on the platform where they generated the data. So we do a wide range of capabilities that we support here with the Data Direct Networks hardware. Like I said, we've had a big, long relationship with DDN. They've supported many of our research activities, and they've really helped us out, especially in this event of COVID. More than 25% of Frontera's computing time was actually allocated to support COVID-specific research. And this was kind of a high priority activity, and DDN stepped up and helped us with making sure that they had full support on the storage hardware and keeping us up and running while we were doing those research computing activities. One thing we're really excited about and the upcoming technologies that DDN is going to be offering is the product Red. DDN approached us about this a little while back and knew that we had some hardware available that we could potentially do some testing as part of our Frontera project. And of course, we're trying to evaluate new technologies that we might deploy for future systems. And when DDN approached us about this, we were pretty excited about being able to participate and help them, deploy the product, test it out, kick the tires, give them some initial feedback early on. We realized it was very early beta testing, but luckily enough, we were able to give them access to our hardware. They set up the initial deployment, confirmed all the IME NVMe flash storage was working with the Red product. I gave them access to a couple of clients. They have mounted on the clients. Everything was working very well communication-wise. Then they actually turned the hardware over to us with a blank slate. And the goal is to make sure our admins could easily spin up Red, get it mounted, get it running without too much effort, and without having to go through the pains of managing and configuration that is typical with a lot of these big complex file systems. Sure enough, a couple of our administrators were able to easily deploy the product onto the servers, got the servers all up and running, got them communicating with each other. And then sure enough, we were able to deploy on the clients and get it mounted. Now this is very early on. There's still a lot of developments to be done and still pretty early, but I think the initial stages show that the new product should be capable of handling the performance and capabilities of the flash storage, along with supporting the level of activities and interaction we need on our client side so that our applications can really leverage what Red can provide to us. So we're really looking forward to the next release. In fact, we're still testing. They just implemented a new release. They're testing on some servers we have. We hope to be able to deploy it at larger scale upcoming. Currently, we only have 8 servers that are running it, but our plan is to take our current IME burst buffer, divide it by half, and take 1.5 petabytes of that storage and put the Red product on it, and actually get users access to it and let them actually try to start using it. Once it gets a little further along, we realize that early on it's API related. We need to have more of a storage block layer that's upcoming in a future release. So again, we're pretty excited about this. We like the technology and like the ideas of leveraging what's available and the capabilities that NVMe can provide us, and still getting the absolute best performance that we can get and scale out. The systems keep getting bigger. Storage has still been our biggest bottleneck. The amount of data analytics and read-write bandwidth required for some of these AI machine learning applications is really driving the needs for a product like Red. In summary, I do want to say thanks to DDN. They've been a great partner. They've been a very helpful vendor in terms of providing solutions to us to meet our storage needs and requirements. Especially Alex and Paul for helping us and talking with us. I'm afraid we won't be there to see you at supercomputing like we always get to do, but we do hope to have some virtual meetings and some further discussions. And we really do value the customer vendor relationship we have with DDN. Anytime we've needed some type of storage product, we approach them about our potential needs. They come up with a solution that meets what our requirements are. And that's one of the things I really enjoy about working with DDN is, I can try new technologies. I can push the boundaries of what the storage capabilities can do with the products that DDN has provided to us.